Let's start with a simple, eye-opening comparison. If you use a standard Google search to find a recipe, the servers process that request and give you an answer using roughly 0.3 watt-hours of electricity. It is so small, you wouldn't even notice it on your power bill. However, when you ask an AI model like ChatGPT to generate that same recipe for you, it consumes about 2.9 watt-hours. That is nearly 10 times more electricity for a single command. Now let's do the math on a global scale. We have hundreds of millions of people asking multiple questions, creating images, and even writing code using these models every single day. If you multiply that 2.9 watt-hours by the total volume of daily interactions, you move away from watt-hours and into the realm of terawatt-hours. In 2023, data centers running AI were consuming electricity comparable to the entire national power grids of countries like Argentina or the Netherlands. Think about that, a whole nation's worth of electricity just to run software. But why is AI so much hungrier than a traditional search engine? The answer lies in the hardware. Traditional data centers, the ones that have hosted the internet for the last 20 years, run on standard CPUs. Those chips are designed to do many tasks at once, like sending emails or storing photos. But AI is fundamentally different. To generate a coherent sentence, an AI has to perform billions of probability calculations every single second. It doesn't look up a database like Google. It calculates the next likely word based on massive statistical models. This process requires a specialized piece of hardware, the GPU, or Graphics Processing Unit. The most famous one right now is the NVIDIA H100. A single H100 chip is a powerhouse of engineering, but it is also a power hog. At peak load, a single chip can consume up to 700 watts of power. To put that into perspective, if you had a household microwave running on high power, that's about the same electricity draw. Now imagine a single room in a data center packed with 30,000 of these microwaves, all running at full blast 24 hours a day, 7 days a week. The amount of electricity needed to simply keep those chips powered is staggering. But electricity is only the start of the infrastructural burden. The bigger problem is the heat. When you pack 30,000 of these high-performance chips into a confined space, they generate an incredible amount of thermal energy. If you didn't have a cooling system, the heat would cause the silicon chips to melt within a few minutes. This is why data centers have shifted from simple air conditioning to complex industrial cooling systems. Many are now using liquid cooling, where water is pumped through pipes directly into the racks where the chips live to carry away the heat. This brings us to the hidden cost that almost no one talks about: water. Researchers have studied the water footprint of AI models and found that generating just 20 to 50 prompts requires the evaporation of about 500 milliliters of fresh water for cooling. This is the volume of a standard water bottle. In areas where water scarcity is already a major crisis, like in parts of the American Southwest or regions in Chile, this creates a real conflict. We are essentially choosing between having enough water for local farming and communities or having enough water for AI to stay cool enough to generate content. We are seeing local communities push back against the construction of new data centers because they know the reality. These buildings don't create many local jobs, but they take a massive share of the local water and electricity. The tech giants aren't just software companies anymore. They are now the single largest consumers of physical resources in the areas they inhabit.
We established that AI is essentially a high-voltage monster that consumes electricity and water at an unprecedented rate. But here is the real crisis. The world's existing power grids were never designed for this. A modern AI data center doesn't just need power, it needs baseload power, massive, steady, 24/7 energy that never flickers. This is why tech giants like Microsoft, Google, and Amazon are suddenly abandoning their purely green image of wind and solar and turning toward the most controversial energy source on the planet: nuclear power. For decades, the nuclear industry was in decline, especially after accidents like Chernobyl and Fukushima. But AI has changed the math. You see, wind and solar are great, but the sun doesn't always shine and the wind doesn't always blow. AI, however, never sleeps. To bridge this gap, tech companies are now leading a nuclear renaissance. In late 2024, Microsoft signed a massive deal to help restart a retired nuclear reactor at 3 Mile Island in Pennsylvania. Now, if that name sounds familiar, it's because it was the site of the worst nuclear accident in U.S. history back in 1979. For Microsoft to go back there tells you everything you need to know about how desperate they are for power. They aren't just buying electricity, they are essentially funding the resurrection of a dead plant just to feed their AI servers. This single plant will provide over 800 megawatts of power, enough to light up nearly 1 million homes, but it will all go straight into the digital brain. But it's not just about old reactors. Google and Amazon are placing their bets on something even more futuristic: SMRs, or small modular reactors. Imagine a nuclear power plant, but instead of a giant, terrifying dome, it's a small factory-built unit that can be shipped on a truck and placed directly next to a data center. These SMRs are designed to be safer and cheaper, but there's a catch. Most of this technology is still in the testing phase. We're essentially betting our energy future on a technology that isn't fully ready yet, all because we need AI to be faster. This creates a massive infrastructural conflict. A new AI data center can be built in about 18 months. However, building or even restarting a nuclear reactor takes at least 10 to 12 years due to extreme safety regulations. This means there is a time gap where the demand for AI is growing faster than our ability to generate power for it. What happens during that gap? Tech companies start outbidding everyone else for whatever electricity is left on the grid. In some parts of the world, this is already happening. When big tech buys up all the clean energy contracts, the local community is left with the dirty energy, like coal or gas. Or worse, the price of electricity goes up for the average person because a data center nearby is sucking up all the supply. We're moving into an era where tech companies are no longer just software providers. They are becoming private energy utilities. They are buying the power, the water, and the land, creating a private energy oasis while the public grid struggles to keep up. This isn't just a tech story anymore. It's a battle for the very resources that keep our modern world running.
We have reached a critical point in the AI revolution. We saw how AI devours electricity like a small nation, and how tech giants are resurrecting nuclear power to keep the servers running. But this leads us to the most important question of all. Can we ever make AI efficient enough to save our planet? Common sense tells us that as technology advances, it becomes more efficient. And it's true. Engineers at NVIDIA and Google are working tirelessly to create chips that can perform more math per watt. Every new generation of AI hardware is significantly more energy efficient than the last. But here is the terrifying reality of economics, known as Jevons paradox. Jevons paradox states that as a resource becomes more efficient to use, the total consumption of that resource actually increases rather than decreases. Think about it. Because AI is becoming cheaper and faster to run per query, we aren't using it less, we are putting it into everything. We are adding AI to our toasters, our cars, our emails, and every single software on Earth. The efficiency gains are being completely swallowed by the sheer explosion in demand. We are running faster just to stay in the same place. This brings us to the physical wall. Even if we solve the energy crisis with nuclear power, we still have the water crisis. In 2024, Microsoft's global water consumption spiked by 34%, and Google's rose by 20%, directly linked to data centers. We are reaching a point where local governments are forced to choose. Should we approve a new data center that brings in tax revenue, Or should we protect the water supply for the local farmers? In places like Uruguay and Spain, citizens have already taken to the streets to protest data centers versus drinking water. So, what is the endgame? Some believe the answer lies in edge AI, processing the intelligence directly on your phone or laptop instead of sending it to a massive, thirsty data center. If your device can handle the thinking, we reduce the burden on the global grid. Others are looking at biocomputing, or neuromorphic chips that mimic the human brain. Your brain is the most efficient computer in the universe. It can perform complex reasoning while consuming only about 20 watts, the same as a dim light bulb. If we can make chips that think like humans, we might solve the energy problem. But until that breakthrough happens, we are faced with a final choice. As a society, we have to decide, how much intelligence do we actually need? Do we really need a massive, energy-sucking AI model to help us write a 2-sentence RSVP for a birthday party? Do we need to burn a bottle of water just to generate a picture of a dog wearing a hat? The true price of AI isn't the $20 monthly subscription fee. The true price is being paid by the power grids, the freshwater reserves, and the environment. We have built a mirror of human intelligence, but for the first time, we are realizing that this mirror requires a massive amount of Earth's blood to keep reflecting. The AI revolution is here to stay, but its future won't be decided by coders in Silicon Valley alone. It will be decided by the physical limits of our planet. We wanted to touch the stars with AI, but we must make sure we don't burn down the forest just to build the ladder.